Welcome friends. Here a question related to the previous JEE and it is related to the matching. And the matching content of the questions of column A and the column B are given by. It is related to the matching of isomers versus the type of isomer that it belongs, and the list of contents are given by. Here the list of isomers, those are provided for us in the form of options are given by. This is 1, whereas this is B, this is C, followed by this is D. In case of A, it is consisting of propanamine followed by N-methylethanamine. If I write the structures, the zigzag form, if I write, this is propanamine, whereas the second one that is associated with the propanamine is N-methylethanamine. This is N-methylethanamine. These two are as option A, whereas hexane 2-1, it is a 6 carbons containing system, that is hexane 2-1 followed by hexane 3-1. Hexane 3-1 is the system. Along with this is ethanamide. Ethanamide stands for, this is ethanamide, whereas this ethanamide is associated with another one, that is ethanimine, hydroxyethanimine, that is CH3 followed by this is the hydroxyethanimine, whereas the last one orthonitrophenol followed by paranitrophenol. This is orthonitrophenol. The next one is paranitrophenol. Like this, 4 compounds combination is provided. For these compounds, a proper combination of type of isomerism is asked for us. I will write by erasing these things in the place of isomers, the type of isomerism. On writing the corresponding associated type of isomerism given for us, the type of isomers, those are provided are metamers, positional isomers, functional isomers followed by tautomers. If I go for this propanamine followed by N-methylethanamine, these two will become functional isomers. Whereas, as we know, this is primary amine and this is secondary amine. These two belongs to the category of functional isomers to one another. Whereas this hexane 2-1 and the hexane 3-1 belongs to the category of positional isomers, followed by they also belongs to the category of metamers. Whereas orthonitrophenol, paranitrophenol, they are originally just the category of positional isomers, they never becomes the metamers. Hence we will give this particular orthonitrophenol and the paranitrophenol as a proper option of positional isomers. Then this metamers belongs to the category of hexane 2-1 followed by hexane 2-1 and the hexane 3-1. Whereas tautomers, this particular amide and the hydroxyimines belongs to the category of hydrogen shifting based tautomers. So therefore the proper correlation between the provided isomers and the type of isomerism is given by S. This is propanamine and the N-methyl propanamine belongs to the category of positional isomers, whereas hexane 2-1 and the hexane 3-1 belongs to metamers. Positional isomers are orthonitrophenol followed by paranitrophenol, whereas this ethanamide and the hydroxyethanimines belongs to the category of tautomers. Thus, the isomers and the isomerism is present like this. In the same content, the next question asked for us is, this is question number 31, whereas the number of acyclic stands for non-cyclic. So we are not considering any kind of cyclic partner. Non-cyclic structural isomers, including geometrical isomers, possible for pentane system are of how much? Suppose if I take pentane is C5H12. I have to write, it might not be pentane because we are expecting geometrical, might it is pentene system. Pentene stands for C5H10. C5H10 stands for alkene system. So one double bond is present. Whereas if I write the possible structural formula of the C5H10 in various ways, from that I have to extract the number of acyclic. Cyclic is not considered. I have to write only the cyclic. The cyclic total number of possible isomers of the, including geometrical isomers of the pentene system are. Whereas pentane a 5-membered system, if I write a linear 5, I can keep double bond at this place. I can keep this linear 5's double bond at the second and the third carbons combination. Suppose if I extend this one, this also becomes the same and this also becomes the first one. Hence, in two ways we can write. Whereas if I go for one substitution, 1, 2, 3, 4 followed by one substitution, I can keep double bond here and at the same time I can keep another one double bond here. We can also having another one chance to this to write as like this. Suppose if I go for the 4 plus 1 followed by 3 plus 2 combination, this is 3 plus 2, there is no chance for us to write any kind of double bond, hence it doesn't fit. In 5 ways we can write. Out of these 5 ways, if I want to really go for all possible varieties, in this case geometrical isomerism is not possible, hence it offers only one structure. If I go for this structure, here methyl is there, here ethyl is there, here hydrogen is present, here hydrogen is present, it is trans. Similarly, I can write for this cis also, hence two isomers are possible. In this case, two are hydrogens. As being these two are hydrogens, no geometrical isomerism is possible, only one. Here also two are methyls, hence no geometrical isomerism is possible, only one. In this case, two hydrogens are present, hence no geometrical isomerism is present, only one structure. Though I can write 5, from that 5 I can extract and I can get another one. So therefore, total 5 plus 1 is existing in the form of cis and trans combination. So therefore, extra 1. So there are total 6 varieties of combinations. 6 structural isomers can be obtained for the pentene system. We can write it as 1 pentene, we can write it as 2 pentene. Similarly, I can write it as, where is that one? 1 pentene followed by 2 pentene. Followed by here the name of the compound is 3-methyl 1-butene and it is 1, 2, 3 3-methyl butadiene and here also that is 2-methyl butadiene, and in this case there are cis and trans isomers are possible. So therefore the total possible number of ways of adjustment of molecular formula and the compound, that is pentene, is of 6 different possible ways.